Hello, in this video I want to show you how to use the VieSched++ multi-scheduling feature to create an optimized schedule. And we will, for an example, create a schedule for an R4 session. So let's start. First of all, you need to select the sched catalogs that you want to use. So in this case, I will select the standard sched catalogs and I will use the geodetic good source list. Please always make sure to use the latest version of the sched catalogs. As I said, we want to create a schedule for an R4 session, so I need to change the observing mode to the right one. So in our case, this is the right observing mode. So let's select it. Down here you see the signal to noise ratios that we want to achieve. So our threshold is a signal to noise ratio of 20 for X band and 15 for S band. So we can leave this as it is. Let's go to the general setup. So since this is an official IVS session, we can have a look at the schedule master. So let's have a look. The R4 sessions are listed in this 24-hour block. And let's select the next R4 session, which should be updated. And that's that one. So let's simply copy this line, paste it in here and pass the input. And it will automatically select, fill out the session code, a description. It will select the right starting day, and yeah, and also the network, of course. So for the R4 session, in general, we want to use fill-in mode as always, and usually we also want to use subnetting. But this time we want to select this parameter via the multi-scheduling tool. So it doesn't really matter if you select or deselect it now, as we will see later. Let's have a look at the network. So this network or this session contains 11 stations and the stations are placed all over the world. So this is the list of stations. And as I said, we want to use the geodetic good source catalog, and this is the distribution of the sources that we are allowed to use. Let's come to the parameterization. So I just want to adjust the default parameters slightly. So I will change the default parameters a little bit, and I will in particular change the minimum scan time to 60 seconds for this experiment. So let's change it and apply. Okay. And then we need to check if there is an intensive session at the same time. So it was day of year 163. Let's have a look at the intensive. If there is an intensive at the same time. And there is one. In particular this one, and this is with Cookie, Svetloe and Wetzel. And it starts at 6:30. Okay. Okay. Now I want to create a new station group with these three stations. So this was Cookie, Svetloe and Wetzel. And let's give this group a new name. Let's call it, these are the intensive stations. Because I will now add some downtimes for these stations. So let's add a new parameter and say, okay, the stations are not available during this time period of the intensive. I call this intensive downtime. And the start was 6:30. That's also the start time of this session. And the intensive was for 1 hour. So I will give the stations 5 more minutes to change the schedule. It's maybe a little bit tight, but yeah, they can do it. And let's add the setup here. And now we can check, okay, it is the intensive station. So it's Cookie, Svetloe and Wetzel are using this parameter. The parameter sets the availability of the station to false during this time period. You can also see it down here on the visual overview that there is a new parameter at the start of the session. It's valid from the start until a little bit later, and it's only for Cookie, Svetloe and Wetzel. Okay, that seems okay. And I don't really have to change the source parameters at all, and also the baseline parameters. I will leave them to the default values for now. Let's have a look at the weight factors. And as I said in earlier videos, the weight factors, they are really important to create a good schedule. So I will use the multi-scheduling feature this time to select good weight factors. And therefore it doesn't matter what I've selected here right now, because we will override it with the multi-scheduling feature. Let's also have a brief look at the output, and very important is that we create a sched file, a vex file, an operator node file, and because we also want to make simulations in part 2 of this video, we want to create empty NGS files that we can then use in VieVS for simulations. So that's the idea here. Okay, make sure that you are also select all these output files. Okay, and then finally, let's have a look at the multi-scheduling feature. So this time we want to enable multi-scheduling, and we really want to change, in this example, we want to change the weight factors, and we also want to allow subnetting, or sometimes don't allow subnetting. So the first thing we do here is we select this subnetting parameter. So we add a parameter here, and here it now lists, okay, the list of possible values for subnetting are true and false. And it also says here the total number of schedules that it will create now is 2. And what it will do now is, so far, it will simply create one schedule using subnetting and one schedule without using subnetting, because these are the list of available values that it has. It just has true or false. Let's go to the weight factors, because we also want to vary them a little bit. So let's change it a little bit for the sky coverage weight factor. And here we need to again tell him which values are allowed, which values can he use, and which values should he try. So, and you can either add the values here by hand that you want to use, which is a lot of work. So in our case, we simply want to automatically generate them, and we want to start with a value of 0.33, and then we want to create values with a step of 0.33 until we reach 1.0. So we will have these 3 values which are allowed to be taken for the scheduling. Let's add them. Do the same for the number of observations. So again, I want to allow him to use either 0.33 or 0.66 or 0.99. Let's add them. For the duration, I already know that the duration is a very important weight factor, so I will only allow a little bit higher weights here. And also the idle time, I'm not so sure what's the best one, so I will simply allow a little bit more. So let's talk about this for a second. So in total, now it will create 106 schedules for your session. And it will, for example, create the first schedule using all of those parameters which are displayed here right now. So here you see all the allowed values, and it will, for example, now create a schedule with subnetting, and it will give the sky coverage weight factor a value of 0.33, the number of observations a value of 0.33, the duration also a value of 0.66, and idle time a value of 0.33. And with those values, it will create a schedule. And then it will change one of these values a little bit. And now create the second schedule with those values. Then it will change it again. And now it will create the third schedule. And then maybe change the next parameter and change it again. And it will change all parameters until every combination is created. And every combination in this case are 106 schedules. So yeah, so that's what's going to happen. And here you're just saying which values are allowed, which one should be used for the testing or for the multi-scheduling feature, and this value will then override the values that you have selected in the graphical user interface. And that's why I say it doesn't really matter if I select this one subnetting here or not, or it doesn't really matter which value I give the weight factors here, because the multi-scheduling feature will override it, and it will create one schedule with those values and one schedule with those values, and so on. So it will create all possibilities. So I've only varied 5 parameters here, but you can see here there are a lot more, and oftentimes you simply have to try which one is the best one for you. My recommendation is that you will start with the weight factors, since they have the biggest influence on your schedule. And oftentimes there can be a lot of possibilities, and so but you can limit the number of schedules it creates. So for example, if you don't have a lot of time, simply say I just want to create 20 schedules, and then it will randomly pick 20 out of all these combinations and only create 20 schedules. And you can also give this then a seed, some numbers, that the next time you again create 20 out of this parameters, so 20 schedules, then it will select exactly the same 20 ones that you have selected before. But that's just if you want to really do some comparisons a little bit more sophisticated and so. But usually, oftentimes you can leave this to all because you want to create, let's say, all the 106 schedules. Okay, you can also play around a little bit how to distribute your jobs, because you're using multi-threading. So if you have multiple CPUs in your PC, then it runs in parallel. But yeah, usually leave it to the auto default parameters, and they should work fine. Okay, one final step is that, again, usually I want to add a condition, and my condition should be that all scans or all sources should at least be scanned 3 times. So that's what you usually want. And then let's simply start it. So it will start your schedule, and as you can see, it creates many schedules in parallel now. So you can also see this in the log file down here, that it is creating the schedules, and it will also note that there is currently one process running. You can always terminate it, but they're running independent of the GUI, so you can still use the GUI as you like, and on the background it will create the schedule for you. And yeah, so I will terminate this now because this would take a couple of minutes, and I've already I've already created one schedule on a different PC. So let's have a look at the output. So here on this server, I've also created this multi-scheduling here for the R4 session. Let's have a look at the log file in more detail. So again, it starts by with the initialization of the schedule, and it says which observing mode is found, how many sources, how many stations, how many baselines are participating. Then it says, oh, that he has found the multi-scheduling, so it will create 106 schedules now. And then it says, okay, you want to create them in parallel, so it will create a parallel pool, and it will distribute the jobs out this on 32 cores. So this is a very good server. So I have 32 CPUs, so I can run 32 schedules in parallel on this server. And then here is the standard output. So it starts with schedule number 1, number 92, number 33, number 53, and so on. So it will randomly select schedules and then schedule them. And you can also see here that the log file has changed a little bit. So here you see additionally the thread ID, which is currently creating the schedule. So this is more or less all threads that are available on your PC. And you can see that, for example, schedule number 1 was calculated or is calculated on this thread, and schedule number 92 is calculating on this one, and schedule number 53 is calculated on this one. So they're running parallel, and this is only for you. So if you find any bugs or want to trace down what's happening, then you can use this information a little bit to see which core of your CPU was doing which part of the schedule and all that. Okay, let's simply close this one. Let's have a look at the output. So what was created now? So this is the output directory that was created. And here we see, first of all, that we have now a lot more files than usually, because we are creating 106 schedules. And additionally, you see that there is a version number now at the end. So this is, for example, these are the NGS files that we will use later in part 2 for the simulation. And this NGS file here, this is the NGS file for schedule version 001. And this goes all the way up to schedule version 106. And by the way, okay, I've already closed it, whatever. And yeah, by the way, so in case you want to have a look at the log file again, it's always saved at the output directory as well. So here is the whole log file in text form, because I only want to show you one nice thing. So at the end, you can see that the scheduler is closing, and here you get a rough idea of how much it did. So in this case, it has tested 85 million scans, and it also tested over 650 million observations and 400 million antenna pointing. So it was quite a big schedule. It took it on the server 4 minutes to create those 106 final schedules. So that's quite good. Okay, let's go back to the output files. So as I said, here are the NGS files, and then you get for every version, from versions 1 to version 106, you get here the SCAD file, the operator node file, the VEX file, also the iterative schedule creation. So it was creating this schedule, then it was checking the optimization conditions, so if there are enough scans for each source, and then it's creating the next iteration and so on. So in fact, it hasn't really created 106 schedules, but it has created many more, because it was doing it iteratively. Yeah, in total, if you want to check, you see it has almost created 700 schedules for this session here now. Okay, but only 106 of them are the valid ones. So, and they are all listed here and displayed here. And if you, for example, now open any of those operator node files, then you can see which parameters have been used. And for example, here it always notes the schedule was created using multi-scheduling tool. This was version 12. Subnetting in our case was disabled. The sky coverage took, and these were the weight factors that were used, for example, here. And if I now have a look at the next one, then I will see that it's up here, that the versions are slightly different. So here the difference between, let's try to line it up. Okay, a little bit down. So the difference here is that it was, on one hand, for one schedule was using subnetting, for the other schedule it was not using. Here it was using subnetting, and for the other ones it was not using subnetting. And also the parameters are a little bit different. So these are basically the differences from the multi-scheduling feature. So it was creating the schedule using different parameters. Okay. And then you have all this output. So you have 106 possible schedules. Now, let's have a look at them, or let's compare them. So let's go back to this PC, because now we want to have a look at the statistics tool that we have implemented in VieSched++. So here you can add one of the statistics file, and I will show you again. So if in your output you get all these files, and additionally you get this statistics CSV file. If I open it, okay, maybe not with LibreOffice because it's a little bit bigger. Let's simply open it with gedit. Then you see this is basically a file full of statistics. So it's a big file with a lot of statistics for each version. So for example, for version number 80, the number of scans is 1082, and so on. So you get a lot of numbers here that you can use to select the best schedule for your purposes. And there's a very convenient way to do so via the statistics feature in VieSched++. So here you can add one of these statistics file. For example, this statistics CSV file here. This is the one for the R4 session. And here you can now have a graphical overview of all your versions. So this is version 1 up to, so this goes all the way until version 106. And here are some bars which are showing you some variables that you want. So for example, by default, it shows you the scans, the number of scans and the number of observations, and the number of scans are displayed in blue and the number of observations are displayed in green. And if you hover any element, it will add you additional information about this element on the top right here. So if, for example, Version 1 consists of 1106 scans, and it also contains 10,547 observations. And version 2 is a little bit different number of observations, different number of scans and all that. Okay. As you see here, the absolute values between number of observations and number of stations is quite different, and to improve the visualization you can also have a look at the relative values. So here is only the relative value shown, so the highest number of observation gets displayed with a bar of size 1, and the lowest number of scans, or a scan of 0, would be just very tiny here. So that's just the absolute view of the number of scans and number of observations, and this is the relative view. Usually you want to have a look at the relative view, and usually you will always also remove the minimum. So that's basically you're looking at the same numbers here, but they are displayed differently. So here, if you select this one, you can spot differences a lot easier. Okay. For example, you can see now that the first number was with the 10,500 observations is one of the bigger ones. So there is obviously some schedules which have even more observations, but also a couple of which are less. And you can also sort this, you can also sort the appearance of the schedules here. So for example, if you want to have a look at which station or which schedules have the highest number of observations, then you can simply give this a weight here, and then it will weight it or sort it due to the number of observations, and you will see here that this version number 35 is the version with the highest number of observations, in our case 11,000, and the next highest number of observation is for version 21 with 10,900 and so on. And this goes all the way down to version number 87. Version number 87 is the least number of observations. And this is basically, so again, if I would change this, for example, I would not remove the absolute values, then you would see, okay, the differences are a lot smaller. So all this does is really just to display them differently. So here it stops at some values and not at 0. So that's this one. And if I would look at the absolute values, then I will see, okay, again, here it's a little bit harder to spot. So that's just for you to improve visually improve or see the differences a little bit better. And as you can see here, so I've now only looked at the number of scans and number of observations, but there are way more different quantities that you can look at. For example, you can also look at how many observations are there for photolaser, for example, and add this new bar to our statistics view here. Or you can, for example, also look at, for example, let's have a look at subnetting. So subnetting, are the schedules created with subnetting, yes or no? And you see, it's also quite interesting that the subnetting is now displayed in red, and subnetting only knows two values, so true or false. So if there is a red bar, then the schedule was created with subnetting, and if not, it was not created with subnetting. And you see that we have now sorted the schedule according to the number of observations, and you see that if you look at the schedules with the highest number of observations, then they all use subnetting. And so here, this is the first schedule which is not using subnetting, which has then the highest number of observations. And then on the other hand, as soon as I really go down to the schedules with the lowest number of observations, they are all not using subnetting. So subnetting in this case really helps us to get a good schedule. And you can also look at different parameters that you have set. So for example, there are a lot of metrics here. For example, you can have a look at the duration of the schedule, also the weight factor for the duration, enable it, and see, okay, also if this is an important metric for you or not. So there is a lot that you can play around, so a lot of parameters you can enable or not, or disable. You can also see, for example, on average, how much observing time is there for all stations, or really how much observing time is there for some particular station. So you can really add a lot of quantities here and select it and change it. There are also quantities about the sky coverage. So again, on average, how good is the sky coverage if you distribute the sky in certain areas over 60 or 30 minutes. Yeah, you get a lot more idea about this when you read the VieSched++ paper. So I've described this here, how this is calculated. But in the end, the important stuff is that you have now created 106 schedules, and you have here with the statistics tool, you have a tool built in VieSched++ that lets you compare these 106 results quite easily and quite nicely. But of course, oftentimes that's not enough, because how can you say that a schedule with, I don't know, 11,000 observations is really better than a schedule with 10,900? So there are more quantities, because usually you want to create and use a schedule which has the best EUPs, or which estimates the best EUPs, or which lead to the best coordinates for the stations, for example, estimates or something like this. And that's why you need simulations for. And this is the second part of this video that we will go through, because we will now use the NGS files that we have created in VieVS, and we will create large-scale Monte-Carlo simulations for the whole session. Okay, this was it for the multi-scheduling feature. I hope it's a little bit clearer here, and yeah, thanks for watching.